Just like in alkenes, alkanols also have isomerism. However, they have more types of isomerism. Alkanols show both positional isomerism and branched or chained isomerism. Positional isomerism in alkanols is the position of the OH functional group in the carbon chain. For example, if we have ethanol, let us use another example of propanol. Our OH group could be there. We could also have propanol with the OH group attached to another carbon apart from the terminal carbon atom. Notice the functional group in this case is attached to carbon number 2, while the functional group in this case is attached to carbon number 1. These two would have the same molecular formula of C3 H7 OH, C3 H7 OH. However, the position of the functional group is different. Therefore, these are positional isomers of propanol. We'll come to how we name these two. They have a slight difference. The next type of isomerism, we've already talked about this, propan 1 all and propan 2 all is what I wanted to talk about. The naming. Since the OH group is in the first carbon atom, therefore we'll say propan 1 all. Since it is in the second carbon atom, then it is propan 2 all. Branched isomerism in alkanols is where the molecular formula remains the same, but the arrangement of carbon atoms differs. For example, the isomers of pentanol. We have several of them. We could have this first one. Let us focus on this one. The functional group, which is the OH group, is attached to the first carbon atom. Therefore, it is pentanol or pentan 1 all. In this second example here, the OH group is attached to the second carbon atom. Therefore, it will be pentan 2 all. Moving on to the third, the OH group is attached to the third carbon atom. Therefore, this is pentan 3 all. These three are positional isomers. When we move to the fourth example, this one is an example of branched isomer of pentanol, because we have a branch, a methyl branch in the longest chain. Therefore, even though the molecular formula still remains the same, the arrangement of carbon atoms is different. So in this case, this would be 3-methyl butan 1-ol. We could also have the 5th one, which is another branched isomer, which is 2-methyl butan 1-ol. The next example is another case of branched isomerism. In this case, notice the functional group is in carbon number 2, and the longest carbon chain is 1, 2, 3, 4. Therefore, it is still a butanol. So this one is 2-methyl butan 2-ol. The 7th example is 2-methyl butan 3-ol. I beg your pardon. We could also have this one is 3-methyl butan 2-ol. And finally, we have since we have 2 methyl groups attached to the second carbon atom, therefore it will be 2,2-dimethyl. The longest chain contains 3 carbon atoms, therefore it is propan 1-ol. So these are all the branched and positional isomers of pentanol. Let us do some practice drawing some alkanols. Draw the structure of the following compounds: 2,2,5 trimethyl hexanol, what about ethane 1,2-diol and 2,3,4 trimethyl pentan 3-ol? I'm going to assist you to draw ethane 1,2-diol. Since it is ethane, it has 2 carbon atoms, and it is a diol, that means it has 2 functional OH groups, and therefore the structure is drawn as follows. This is ethane 1,2-diol.